last one. The words spoken in a day by women have a mean of 16,215 words and a standard deviation of 7,301 words. What are the number of words that separate the unusual word counts from those that are usual? So what they're trying to get at is that, remember, we're going back to we don't have a z value. What you would do is you'd put what goes in the middle is your mean, which in this one is the 16,215. And to talk about what separates those from what are usual and unusual, remember that you've got to find the upper end, which means you'll add 2 standard deviations, and then the lower end you'll subtract 2 standard deviations. Now they did give us the standard deviation, that's the 7,301. So to find this upper number, I'm going to have to add the 7,301 twice to my mean, the 16,215. So let's do that. Let's take the 16,215 and add the standard deviation 7,301 twice. Or multiply it by 2 and then add it. Either way, what that gets us is a total of 30,817 what? We were talking about the words spoken, so words. Then we need to do the same thing for the lower end, and that would be to take your mean and subtract the standard deviations twice. So I take my 16,215 and subtract the 7,301 twice, or multiply it by 2 and then subtract that, which gets me only a total of 1,613 words. So what's going to be considered usual, which is what they asked, will be anything that's in between the 1,613 and the 30,817. Anything that's in between these two values will be considered usual. Anything higher than the 30,817 or anything lower than the 1,613 will be what's considered unusual. And that's what they were looking at us finding. The next thing we'll look at is percentiles. When we talk about percentiles, for instance, we'll have a percentage. Let's say we'll have the percentile. The P stands for percentile. The 20 tells us what percentile. So this is the 20th percentile. Would mean that on a number line, if you kind of think about it that way, is the 20th percentile would represent that the 20th percentile means that there is 20% of the data below me, which means that there's another 80% above the 20th percentile. So another example would be something like let's say the 90th percentile. On a number line, what that would mean is that 90% of the data is below you, but the other 10% is above you. So the question is, how do I actually find the percentile of a data value? Well, the formula tells us that in order to find the percentile of a data value, that's what this means, percentile of X means the percentile of a data value, is to count the number of values in your data set that are less than your value. Notice it says less than, not less than or equal to, so less than your value, and then divide it by the total number of numbers that you have in your data set, and then multiply that by 100. And remember, multiplying anything by 100 will turn that fractional decimal value that you've got into a percentage. Percentiles, though, must be whole numbers, so we're going to round it to the nearest whole number. So let's take an example. Let's look at this first one and see what's going on. On this first one, we're looking at the data value 41. So the data value 41 which is right here in the data set. Notice they've already done us a huge favor by putting this in order, and it needs to be in order. Why? Because it says that we want to count up the number of values less than our number. Again, remember that it says less than or equal to, so I don't actually want to include 41. I want to include everything below it, which means the 36, the 37, the 37, and the two 39s, which means that there are 5 data values below or less than our 41. And then it says to divide by the total number of numbers. So it says that these were the scores for the past 24 years, so there's 24 values we're looking at. So what that does is then we can do the division, which is what is 5 divided by 24. Well, 5 divided by 24 is 0.208. Then, remember, if we want to turn this into a percentage, we're going to have to multiply by 100, which will give me 20.8%, but it says to round to the nearest whole number, which means I would automatically round up to 21. That means that this is going to be the 21st percentile, the value 41. Now, let's try the next one, same idea. Let's look at the data value here, which is 65. 65, which is way down here in the data set. We still want to do the same thing, counting up all the numbers before 65, meaning less than 65, to keep on going along both lists. Well, if you want to do this a little bit quicker, is remember that there are a total of 24 numbers. That's what goes on our denominator here. There's only 4 that we're not including, so it must be that we're looking at the other 20. So if you don't want to manually count them, you can kind of do that. So then that means we're going to look at what is 20 divided by 24, which is 0.833. So let's turn this into a percentage by multiplying by 100 or moving the decimal place 2 places to the right, which will give us 83.3. Then we round to the nearest the nearest whole number. Well, the nearest whole number is actually now an 83. So this is going to be the 83rd percentile for this one, for the data value 65. Let's try one last one. Let's see, the data value 39. So we'll look at 39. Again, we'll count up all the data values less than 39. Well, less than 39 would be the 2 37s and the 36, which is a total of 3 values out of the total of how many values did we have, which was 24. So we want to look at what is 3 divided by 24, which is 0.125. Now let's turn that into a percentage by moving the decimal place 2 places to the right or multiplying by 100, which will give us 12.5%. Again, we have to round that to the nearest whole number. The nearest whole number to 12.5 is actually, we round up to the 13th percentile. And we're